This lesson is for Unit 3, Lesson 2, Overview of Polynomials. So polynomials are just a grouping of one or more terms separated out by addition or subtraction. So we have multiple different examples here of what a polynomial could be. We could have two separate terms separated by subtraction. Variables could match, variables could be different. It could just be one term, so 3x squared. It could also just be a constant term, so the number 18 is also a polynomial. Another single term polynomial, 4xy to the fifth, z squared. And polynomials could be multiple terms, so separated out by addition and subtraction. There's some specific rules for polynomials. Specifically, a polynomial cannot have a variable underneath a radical sign, and a variable cannot be part of a denominator. So those are the two main rules for polynomials. So looking at these examples, for 5x squared y cubed, I don't see any variables under the radicals, and it's not part of a denominator. So this one is a polynomial. Second example, y divided by x plus 5x. Because we have this x in our denominator, the second one is no. 7 doesn't have any of those issues, so the number 7 is a polynomial. And this last one, square root of x plus 1. Because that x is underneath that radical sign, this one is not a polynomial. There's also different types of polynomials, just the way that they're named. So one term would be a monomial. So there's no addition or subtraction separating terms for a monomial. There's just one term. You could have a binomial where you've got two terms, either separated by addition or subtraction. Or you could also have a trinomial where there's three terms separated by addition or subtraction. Typically anything larger than a trinomial, so anything with more than three terms, we just refer to as polynomials. So if there's more than three terms, they would classify that as just a polynomial. For polynomials, they work similar to variables that we've already worked with. In order to simplify them, we are going to combine like terms. And when you're combining like terms, make sure that the variables and exponents match completely. So if you see anything that has the same variable, letter, and exponent, then it can be simplified. So looking at the example here, I have 4x cubed plus 2x squared plus 4x squared plus x and plus a minus 14. There's actually two of them that match, that have the exact same variable and exact same exponent. And that's this 2x squared and this 4x squared. So you can combine them just like we've done looking at the coefficients. Since they're both positive, we have 2 plus 4. So our final polynomial would be written as 4x cubed plus 6x squared, because 2 plus 4 is 6, and then plus x, and then either plus a negative 14, or you can just write that as minus 14. So for polynomials, just make sure you're always combining like terms, and the variables and exponents have to match. In this polynomial, there's nothing else that we can write or combine together because none of the other ones have exactly the same variables and exactly the same exponents. So another example for combining like terms. Again, look at the variables and exponents. So 7x squared y, 8xy squared, 3x squared, a minus 2x squared y, and a plus 4x squared. So a common misunderstanding that students will have is they'll add these two because they'll see it has a squared exponent, but they're actually different terms because this one the x is squared and the y is singular. This one the x is singular and the y is squared, so we can't actually combine them. And just a helpful tip, when you identify ones that are the same, so 3x squared and 4x squared, they're common terms. I recommend just make sure you watch in front of that number. This one is a positive. This one here is also a positive. So I know when I combine them together, 3x squared plus 4x squared, they're both positive. I just add the coefficients. That becomes 7x squared. And then 7x squared y matches with a minus 2x squared y. Notice it's subtracted here. Treat that like a -2 or 7 minus 2. Don't just look at the number. Always look in front. This one is subtracted. So 7 minus 2 would be 5x squared y. And then our last term, 8xy squared, can't be combined. So plus 8xy squared. So always look in front of each number to make sure what that symbol is. With this one especially, it was a -2. We had to make sure we did 7 minus 2 to get to our answer. Another thing that comes up in this lesson is making sure your answers are in standard form. That just simply means make sure your exponents for your variables go in decreasing order. And if there's more than one variable, then you look at alphabetically first. So for example, if it was 3x squared y, you'd be looking at the x's, not the y's. So you want it in decreasing order. So starting with the largest one, my largest exponent is x to the 4th. So I would have x to the 4th plus, I have a cubed one, so plus 3x cubed plus this 5x term, and then the constant is always last, so plus 28. The plain number will always be at the end. The last part of this lesson is talking about classifying terms by the degree. And what that means is you're looking at the sum of the exponents of the variables. So when you have one term, nothing is separated out by addition or subtraction, you look at your exponents. We have an exponent of 3, 2, and 5. So for the degree, I'm going to add those exponents, 3 plus 2 plus 5, to make this term, this polynomial, have a degree of 10. So since it was just one term, the degree is 10. You add those exponents. Just a couple more examples. This one term, it's a monomial. I can just add the exponents. So 6 plus 4 is 10. 10 plus 2 is 12. So the degree for this one is 12. This one down here, 6 and 3, would have a degree of 9. If your variable does not have a number with it, so m to the 6th, n to the 3rd, let's say we had an O on the end. If there's no number there, think of it as always having an exponent of 1. So you can add that 1 on there. Now finding degrees of multiple terms, you're still going to look at each term individually. So you want to find the degree of each separate term, and then the degree for the entire polynomial will be whichever term has the higher degree. So looking at this one, 2x to the 4th times y plus 4x squared y to the y squared. When you look at those exponents, again, this one didn't have a number. Think of it as being a number 1 there. So our first term had a degree of 5 because 4 plus 1 is 5. My second term, if I add those exponents, 2 plus 2, I get 4. So you're not going to add 4 plus 5 to get 9. You're going to look at the term individually. And this individual term had a degree of 5, so then the entire polynomial has a degree of 5. Okay, you don't add the different terms. You only look at each term individually and find the degree of each one. Just couple more examples. Looking at exponents, 3 plus 3 is 6. So this term has a degree of 6. 4 and 3 is 7. So the degree of this entire polynomial is 7. The bottom one, x cubed, y squared. This term has a degree of 5. X squared, y to the 5th. This one has a degree of 7. So this entire example would have a degree of 7.